Welcome everyone to session 4 of data science for trading professionals and risk managers. In session 4, we're going to talk about model building and statistical learning. Kind of building on the previous sessions, which was ingesting data, cleaning that up and staging it for further analysis. Visualization to get a sense of what the trends are in our data. Usually we get to a stage in analytics and data science that we need to effectively infer certain characteristics from that data and potentially create a model that predicts an event or predicts a trend. There is no one way to do that. I mean, obviously, a lot of us have been doing that without actually knowing it, and we make conclusions from our data, and we do, for example, a linear regression or linear trending, and basically kind of influence decision makers to make a certain decision. And one of the most powerful features of data science and modern data science is the ability to make predictive analytics quite easy and accessible to everybody. Usually, I mean, in the past, this was something in the realm of people with lots of experience and higher degrees in statistics. However, with packages that I'm going to basically show you in R, this would allow everybody to effectively have a shot at running machine learning algorithms and doing predictions using fairly complex statistics. So in this session, I'm gonna talk about a few of the packages. I'm gonna talk about the stats package. It's more for descriptive sort of statistics. We're going to look at a time series forecasting. That's more in the area of ARIMA type models. We're going to look at a package that could be used for outlier detection that was developed originally by Twitter, and now it's available as an open source project that everybody can download and use on their time series analysis. Then we're going to look at the Caret package, which is effectively a wrapper on whole bunch of machine learning packages within R, and there's a huge list. So we're going to basically look at a few of them and to kind of give you a flavor of how that looks like. So we're going to go ahead and load the session 2 files, which was the XTS data series for CAD and USD Bitcoin prices. There's a function which is an easy function, which is kind of very similar to that SDR function in a sense that it gives you a very broad view of how your data looks like. So it gives you kind of very high-level sort of statistics around your data. I tend to use that actually to look at the data quality and see whether I'm dealing with a data series that might have a lot of outliers and potentially have NAs in it, so I need to clean up. But that's kind of, it's a very, very fast way of getting a good sense of your data. However, if you have a large number of columns, it could be quite hard to find what you want in the summary function. So I can basically look at a rolling mean of my data. So just kind of give you a quick demonstration of how easy it is to actually calculate the rolling average of your data. You can also do a similar thing to calculate rolling standard deviation. So that's kind of there's lots of packages. There's lots of examples of how people have done that, and you can basically take a look and use them as you see fit. So I'm going to basically quickly go over a very simple sort of ARIMA type forecasting. Generally, so this is part of a forecast package, and generally in R, what you do is you effectively load the data in a format that the function requires. In this case, it's a time series format, and then you can basically run a ARIMA model on your data. So you get a function or a fit, which if you look at it, it has all the coefficients that you need. So you can basically look at this stage and kind of, if you're a statistician or have experience in statistics, you can basically look at the numbers and run different statistics tests and see whether that fit is suitable. In my case, in the order here is, if you know what you're doing, it gives you a lot of flexibility. However, if you're like me and use a ARIMA model once in a while, and you don't want to spend a lot of time getting into the details of it, you can use a function called AutoARIMA, which basically gives you a recommendation of the best fit with different parameters. Then you can take that fit or that function and then forecast that with a given number of periods. So if this is a daily data, 5 basically would mean that for the next 5 days, what the trend would look like given that model. So if you run this, it gives you the raw numbers, it gives you an upper bound and lower bound with some probability, and then you can basically take that fit and model that. So it gives you a very nice sort of forecast with the range here. You don't necessarily have to use the base plot for this. You can basically take that and, for example, use it within ggplot or any of the different packages which give you better flexibility and nicer graphics. So I'm going to basically quickly go over another example, which is a Holt-Winters model. This is developed by someone. There's usually in R, one of the great things with this is a lot of these models and packages are developed by statistics professors, and there's always generally, actually, not always, there is a paper attached to it which gets into all the details, and it gives you lots of examples and use cases. So you can go as detailed as you want in it, or you can be a user and basically use these plots. However, with everything in statistics and complex math, be careful how to use them, and certain things could be subject to interpretation. So you need to basically keep that in mind. But I think one of the trends right now within data science is actually think about that less and develop better hypothesis testing around your data, and do not get into lots of debate around what's under the hood with all of these models. There are pros and cons to that, but that seems to be the trend, and it actually works rather well in the world of risk management and trading. So here in this case, create a fit using Holt-Winters. You can basically set different parameters within that. It's always, because it's so easy to actually run these functions, you can basically do trial and error and effectively plot your end result and see whether this is something that something that makes sense to you. Whether it's something that you can you can stand behind. For example, here I'm going to basically create a forecast of this data and look at it in the form of data frames. So you basically see the forecast that was generated for 30 periods out, and then you can basically append that to your original data, and you get a time series data as well as your forecast. Similar to the previous example, you can plot that. Obviously, plot looks slightly different than the ARIMA model. You can basically visualize that and kind of get make a conclusion around which model is better representative of your data, which might or might not include a degree of seasonality and a certain trend. So that's in terms of univariate regression type analysis and ARIMA models. There are lots of other packages that you can use that are based off of fairly complicated math, but they have made it so easy that you can basically use them without actually thinking around the complexity. So there are two packages that are developed by Twitter. One is to forecast or to identify breakouts. So it's one of those packages that could be used. I mean, I haven't personally used it in that context, but I think it could be used in terms of understanding regime changes in the prices. And also there's another package which is almost a sister package to the breakout package, which is a anomaly detection. So it runs an algorithm on your data, and then it basically takes numbers that it perceives as outliers. So you have to basically take it as a bit of a black box, which might not be always very comfortable, but for something quick and dirty that you wanna do and basically visualize it and kind of make your conclusions, it's a very in my mind, it's a very powerful package. So I'm gonna basically load both packages, and I'm gonna run the anomaly detection first. So that's looking at the price data, USD price data, and going back in history. And so I basically set the parameters here around what sort of statistics I need, or what percentage of numbers as anomalies. So that factor is actually, you need to read the documentation in detail to understand what that means, or you can just play around with it and see how much of those anomaly points in the data are getting captured here. So effectively, you can basically look at this and look at the history, and the way that, I mean, very much similar to how you would visualize it, this can give you a sense of what are the anomalous points. One of the uses of this is actually running that on pretty much all of your data series, and basically the algorithm would decide what points are anomalies, which then you can basically go and take a look at them. So it could be a function that you could run on your prices that you upload, for example, into a VAR system, or into any of your risk systems, and instead of actually trying to visually looking at them, and then or basically identifying the impact of bad marks, for example, in your data, you can effectively run this algorithm across your prices, and automatically this would flag things that it would flag data points that it would perceive as anomalous. Same with the breakout function. So in this case, you look at the segments of data, and then this package runs a statistical model to understand what are the at what points in the history of these prices there is a significant change in the trend of your data. So here there might be different causes of why that happens. It could be a period of high volatility, or a period of very low volatility and low prices. And this is a good visual in terms of kind of running that in your price series and then looking at it and trying to explain based off of certain market trends why certain price trends are happening. So this can be done obviously looking at your data visually and trying to kind of separate them, but this is more of an automated version, automated way of kind of going through a lot of data and trying to make certain conclusions from them. So that's as far as outlier detection. I'm going to briefly touch on the concept of machine learning. Obviously, this is a fairly broad topic, and there's lots of literature on this, and there are lots of books on machine learning, anything from machine learning cookbooks to predictive analytics, and they're not that difficult to follow and learn, and there are lots of examples that you can basically use and use cases that are commonly used in terms of text mining, natural language processing, as well as some of the Bayesian methodologies and neural networks. So there's lots of resources that you can rely on, and for all of those resources or all of those books, there are whole sets of packages that you can use to actually get all of that done. There are certain basics around machine learning, around segmenting your data and doing a cross-validated sort of test data and tuning, and then using that to tune your parameters within your machine learning algorithm, and then using that to basically validate the goodness of your model. So it's very much rather prescriptive and algorithmic way of doing statistics and creating models, which actually works rather well for business professionals with not a whole lot of statistics knowledge, and it basically gets you started, and you can kind of follow the examples and get where you want to go to. And obviously, like similar to all the previous discussions, you have to be aware that there's certain pitfalls along the way that you need to pay attention to. But otherwise, this has R and a lot of, and also Python to some extent, have made this whole idea of machine learning quite accessible to everybody to try and use. So in this case, what I'm going to do is I'm going to basically take my price series and create lags in the prices. I mean, these could be any parameter. I mean, really, like, one of the powers of machine learning is you can have parameters, you can have time series data and mix and match, and you can have as many of them as possible, as many of the features as possible, and then run algorithms and test out effectively the goodness of your model, and either reject it or kind of use it to make predictions. So I basically ran that. The package that is actually quite powerful, and it's a very good start in terms of learning. You start using machine learning is a Caret package. So Caret package, it's actually part of a package developed by a gentleman named Max Kuhn, and he has a book, is a fantastic book on predictive modeling, which uses this this package quite extensively, and in that he systematically goes over certain use cases for regression type machine learning algorithms, as well as classification type machine learning algorithms, both for supervised and unsupervised learning. So he basically categorizes them, and each of those categories are fit for a certain use case that you might have in what you're doing and what you're trying to predict. So effectively, I mean, generally, you follow a certain number of steps. You might revise it for depending on the package that you're using, but all of that is actually in a kind of written in a very easy format in in a website that pertains to Carrot package. So you can basically look at a simple example and go through it, to tune your model and train your model, and and what are the features or what are the input parameters you need to use to achieve that, and then what are the next steps and how you can kind of make good conclusions and test your model. So in this case, I'm going to basically take my data series, go through it. I'm basically, in this case, like, I'm not doing much, but what I'm doing is I'm basically partitioning my data as a training set and test set, and I basically index it as such. I've created a very small plot, or a very basic plot that basically looks at the features, and it kind of gives you a sense of how they look like. There's lots of these visualizations that help you kind of make certain conclusions about your data even before before the start of the machine learning, or before you start tuning your model and spend a lot of time trying to figure out what's going on. So it gives you a very quick snapshot of of your data and of your features in the data. So in this case, I'm going to use, I want to predict, I'm creating a model based off of USD price returns, and then I'm going to use the lag terms, or basically price returns of yesterday, 2 days ago, 3 days ago, 5 days ago, and 10 days ago. So it basically gives me a sense of whether I can predict a price return now based off of historical price returns, depending on those lags. I mean, this could be anything, obviously. This could be whether I can predict the price returns or the magnitude of price returns in this case, in some cases, based off of other factors, looking at, for example, USD price returns, and then looking at a whole bunch of other currencies to see whether there is some sort of relationship between the two, and whether I can use them to predict the future values of USD price returns in this case. So I basically create the formula. I convert that into a formula. So this is actually a new function that I also want to introduce. So you can basically put in the formula as the text, and using as formula, it changes that to a formula object. So if you look at the actual model, so this would give you a model that looks like that. If you do a str on it, you would see that this is a formula, not character. So the class is formula and gives you in which environment this is saved. So I basically put in some of the training controls, how you want to basically stratify your samples, and in this case it's a repeated cross-validation. There's a great description of what that is in the book associated with the Carrot package, which I highly recommend for everybody to read. So I create that, and here, this is effectively, I'm training my model using a linear multivariate regression. So in many ways, this can be done very easily using the function alone. However, the benefit of using a Carrot wrapper is that you can effectively set up your problem and then loop through the ensemble of different models and different machine learning algorithms, and then basically do a test on the goodness of the fit, and to basically get a better sense of how you can model your data and make better predictions. So in many ways, if you set it up once within this context, it's very easy for you to loop through different examples and basically get to the best model that describes your data. So in this case, this was a linear model. So if you look at the details of it, obviously it gives you some information, and it gives you a sense of the goodness of the fit. So this is very much similar to the example that we had in the session 2 of this series, and you know, you can use either way, but having used this Caret package, you can basically modify this model to something that's a little bit more complicated. For example, the line below is a example of a support vector machine. So it's a nonlinear regression analysis. You can use this for classification problems as well, which means basically some of your predictors are effectively classes and parameters. So it could be a mixed bag of different parameters. Not everything needs to be linear in the world of machine learning. So if you basically run the support vector machine with a couple of more input parameters, obviously this is going to take a little bit longer to run, and so you can look at the data. So very similar to the linear regression, it gives you statistics around the goodness of the fit, and root mean R-square and R-squared values, and root mean square values as well. So it's very much similar sort of setup. It might give you a little bit more information around what was done before, and what was done in the process, and how the model was tuned. So if you're statistically knowledgeable, you can obviously make conclusions about these, and use them to revise some of the tuning parameters, some of the input controls. But if not, I mean, you can always use brute force and kind of go through the model and go through a range of input parameters and just look at the goodness of the fit, for example. The line below, I'm not going to run that. It's a neural network model, which I've commented out. And the reason being that it actually takes a lot of resources in a single node that I have here. But if you have access to more powerful machines, obviously this is a pretty powerful sort of machine learning algorithm that you can deploy, and there are lots of flavors to that neural network that you can use, and it's all documented under the Caret package. So there's a tree-based method. So it's kind of, there's a type of model, tree-based models. It's commonly known. It might have a different name, but I refer to them as tree-based model, such as random forest. And the package here is a package called RPart. One of the benefits and powers of tree-based models is it actually potentially gives you good way of visualizing how your model has been predicted, given different features. You can effectively look at them and plot them, and get a better sense of what a lot of different features, what is the how they interact with the prediction in the model, and it's a fairly quick way of doing both regression type predictions as well as classification problems. So then, I mean, one of the things that I commonly do is, after creating these models, I basically look at them in together, and basically plot them, or basically look at all the samples that were generated. So you actually need to plot these, and it basically gives you a sense of the R-squared number, and what is the R-squared that you want to basically that gives you a better kind of model fit. In this case, obviously, it's kind of looking at individual um, or different tuning parameters that you used in your model. Obviously, in this case, the linear model is actually a better fit from an R-square perspective, but you can use different sort of measurements to get to basically evaluate these models against each other. So you know, in many ways, like using for example that forecast model, you can use you can effectively put in new values and forecast, you know, what is the next event. You know, it's kind of after that is fairly similar to what I showed in the autoregressive models and ARIMA models in terms of using the forecast function within R. There's obviously a lot to be learned about machine learning algorithms and how to deploy them. In these examples, we looked at the regression-based examples, and I think you know, truly the power of machine learning is actually in the classification type problems where you have features as parameters and factors, and mixing that with some of the linear sort of data. And that kind of gives you pretty much, allows you to do prediction on any sort of data sets. You know, it could be on or off, yes or no sort of predictions, or it could be a range of values that you're trying to predict, such as, you know, labeling a data set and things of that sort. And there's a whole set of different ways of looking at and testing whether those models are a good fit to your data or not. It's a little bit beyond the scope of this half-an-hour session, and this is one area that I hope that, you know, we can have more discussions on with the broader group. And, you know, I welcome all the feedback that you have, and if you have interesting ideas around you know, different machine learning algorithms that you have tried, and you know, if you want to share your thoughts, that would be much appreciated. In terms of further readings and learning, as I mentioned, Max Kuhn's book on applied predictive modeling is a fantastic book. It talks about Carrot package in great detail, and also similar to previous segments in this whole series, there's a great specialization in that is offered by Johns Hopkins University and offered through Coursera. And I believe it's the last course in that whole series that you can basically look at, and it talks in great detail on different machine learning algorithms, and it actually uses Carrot package to go through that. So lots of tools, lots of you know, books on machine learning, and it's a very hot topic, and it's a very evolving topic. So and a lot of commercial packages are available as well that you can use. So I hope you enjoyed this session on statistical learning and model building, and I hope you would join me in the last session, which we try to put everything together and create a web application which uses you know, some of the visualizations that we created in the previous sections.